Good evening, viewer. Welcome to our FTV English. Viewers, if you accidentally put your hand on a hot object, you will naturally pull it away first before you have to think about it. So, this happens thanks to sensory nerves in your skin that send a lightning fast signal to your spinal cord, which immediately activates your muscles. So, the speed at which this happens helps prevent serious burns. Your brain is only informed once the movement has already started. So, if something similar happens to a humanoid robot, it typically has to send sensor data to a central processing unit that's called CPU, wait for the system to process it, and then send a command to the arms actuators to move. Even a brief delay can increase the risk of serious damage. But as humanoid robots move out of labs and factories and into our homes, hospitals, and workplaces, they will need to be more than just pre programmed machines if they are to live up to their potential. Ideally, they should be able to interact with the environment instinctively. So, to help make that happen, scientists in China have developed a neuromorphic robotic skin, NRE skin that gives robots a sense of touch and even an ability to feel the pain. Current robot skins are really nothing more than pressure pads that can tell when they are being touched but cannot process the meaning, such as whether it's painful. The NRE skin is different because it is designed to function like the human nervous system. Yeah, this skin consists of four layers. The top layer is a protective cover that acts like our own epidermis. Below all that are sensors and circuits that behave like human nerves. Every 75 to 150 seconds, the skin sends a small electrical pulse to the robot's CPU even when nothing is touching it. So, this is like the skin's way of saying everything is fine. If the skin is cut or damaged, the pulse stops, which tells the robot where it has been injured and it alerts the owner. When the skin is touched, it sends a different kind of signal called a spike, which carries information about the pressures being applied. For normal touches, these spikes go to the CPU. So, however, if the touch is so hard or extreme that it causes pain, the skin sends a high voltage spike directly to the motor. And this bypass of the CPU and triggers a rapid reflex reaction, such as pulling its arm away instantly. A pain signal is emitted only when sensors in the skin detect a force exceeding a preset threshold. Our neuromorphic robotic skin features hierarchical neural structure architecture enabling high resolution touch sensing, active pain and injury detection with local reflexes and a modular quick release repair too, wrote the team in the paper published in the Proceedings of the National Academy of Science. And this design significantly improves robotic touch, safety, and intuitive human robot interactions for empathetic service robots. Amazing, sir. We have this exclusive report.